You ever stare at a really complex exam question and just not know where to even begin? Well, in this explainer, we're going to demystify one of AQA's trickiest graph questions. I'm going to show you exactly how to lock in those full marks. So today, our mission is all about question 06 from the AQA GCSE Chemistry paper. And look, we're not just going to answer it. No, we're going to break down the examiner's mindset so you can go in and claim every single mark. All right, first up, we're going to travel back, way back, like billions of years, to look at the early atmosphere. This covers the first two parts of the question. Okay, so the very first part of the question, 06.1, it zeroes in on region A. And you've got to pay super close attention to that first word, explain. That is a direct instruction, right? The examiner isn't just asking what happened. They need to know why it happened. So if we look closely at region A on the graph, the key tells us that dashed line is nitrogen. And if you follow it, wow, it just shoots right up, doesn't it? It goes from a really low percentage to basically becoming the most dominant gas in the whole atmosphere. So how do we get the 2 marks here? It's a two-step process. First, you state what's obvious from the graph. The percentage of nitrogen increased. Simple. Second, you have to give the reason why. It was because of intense volcanic activity releasing all that gas. You absolutely need both of those points to get the full 2 marks. All right, let's use that exact same strategy for the next part of the question, which is all about region B. And look, the command word is explain again. So what does that mean? We need our what and our why. Now, in region B, the spotlight is totally on that dotted line. A quick look at the key confirms that's carbon dioxide. And man, its percentage just takes a nosedive. It absolutely plummets from being almost 100% of the atmosphere. So to get the marks for this one, first you state that the percentage of carbon dioxide decreased. Easy enough. For that second mark, the mark scheme is actually pretty nice. It gives you a couple of options. You can either say it's because the carbon dioxide dissolved in the oceans, which were just forming back then, or you could say it was because of the formation of carbonate precipitates and sediments. Either of those reasons works. Just pick one and you'll get the mark. Okay, now listen up, because this next bit is super important, and it's where a ton of students slip up. The mark scheme says, very clearly, do not accept references to photosynthesis. And you might be thinking, wait, why? Well, it's a classic exam trap. If you look at the timeline on the graph, all of this is happening before plants and algae even existed. It's such a great reminder that you have to use the data right there on the page to guide your answer. Okay, let's move on. We're now shifting into a really pivotal moment in Earth's history. It's often called the Great Oxidation Event, and it's what the next two questions are all about. So the question now shifts its focus to region C, and we get a brand new command word, compare. Now this is key. Compare means you can't just talk about one gas. You have to describe the relationship between the gases. And if you look at region C, you can see there's a really clear inverse relationship going on. That solid line, which is oxygen, it starts to climb up from basically zero. And at the exact same time, that dotted line for carbon dioxide, it keeps on falling. Okay, so this is a 3 marker. To get all 3, you have to mention both changes. Point 1, carbon dioxide decreased. Point 2, oxygen increased. But that third, really crucial point, the one that gets you the compare mark, is saying that they changed at a similar rate. I mean, you can almost see how the 2 lines kind of mirror each other, can't you? So that leads us right into the next question. What's the process that caused all these changes in region C? I mean, what process takes in carbon dioxide and pumps out oxygen? Think about it. And the answer, of course, is photosynthesis. This is the point in history when early life, things like algae, really started to take off. The mark scheme is super direct here. You get 1 mark for just writing photosynthesis. It does say a correct description of the process would also be fine, but why make it harder for yourself? All right, we're on the home stretch. Let's tackle the final part of the question. This is the one that connects this ancient atmosphere and all that early life to the resources that we actually use today. So for the last 3 marks, the command word is describe. We need to describe how natural gas was formed. And what that really means is just laying out the key steps of the process, one after another in a logical order. And here it is, the perfect 3-mark recipe. Step 1. It all starts with plankton, tiny marine organisms, dying and sinking to the seabed. Step 2, they get covered up by layers and layers of sediment, basically buried. And step 3, over millions and millions of years, they get cooked by immense heat and squeezed by high pressure. That whole process transforms them into the natural gas we use. You just need to hit those key stages, and you've got all 3 marks in the bag. So, there you have it. We've broken down that entire 10-mark question. But what's the big takeaway here? What does this tell you about your exam technique? Well, the key lesson is this. Getting top marks in science isn't just about knowing stuff. It's about how you apply what you know. You've got to be a bit of a detective, right? Use those command words like explain or compare as your instructions. Pull all the clues you can from the graph, and then use your knowledge with real precision to give the examiner exactly what they are asking for. It's a game, and this is how you win it. When you break down questions like this, piece by piece, and really understand the mark scheme, you build the skills and the confidence to turn any tricky question into a chance to shine. So, what's the next question you want us to master together?